Our last topic in permutations is permutations with cases. Sometimes when you try to count something, you can't count it all at once. And it's easier to count it in smaller chunks and then take each of those chunks and add them up, and then you get your total. So sometimes you're counting something, maybe you just got a bundle of money. I don't know how you did this, but you got this suitcase and inside is just a whole bunch of bills all mixed together. And you want to count it. Well, you might separate the 20s and count the 20s, then separate the 10s and count the 10s, and separate the 5s and count the 5s. And then that would be a way of figuring out how much money you have in total by breaking it up into those different parts. Well, that's the basic idea with permutations with cases. We break things up into different parts, and then we add them up to find out the total. So how do we recognize that a question is cases? Well, this one says, how many numbers of at most 3 different digits can be formed using the digits 0 to 9 inclusive? So it could be a 3-digit number, it could be a 2-digit number, it might be a 1-digit number. And so because of that, we would say, well, let's count our 3-digit numbers first. And whenever we're showing our work for cases, we write out case number 1 and describe what we're counting. So let's count our 3-digit hashtags. Number of decisions, 3 decisions. We're using 0 through 9. Any restrictions on here? Yes, there is a restriction. The restriction is we can't start with 0. So there would be only 9 choices here. And since they have to be different digits, that means we can't use repetition. How many choices would we have for our second decision? 9 again, because now 0 could get put back in, but one of the numbers is used up. And now 2 of the numbers are used up. We have 8, and so this makes 648 3-digit numbers. Well, what haven't we counted yet? We haven't counted case 2, 2-digit numbers. So now we would have 2 digits. Again, there's a restriction on this first one that this can't be 0. So there's 9 choices here. We now can put 0 back in, so there's 9 choices there for 81. And case 3 is our 1-digit number. Should I put in 10 or should I put in 9? What do you think? 10. So do we think that 0 is a number as a digit? Yes. So then we could put in 10. And so there's 10 choices there. If we add those all up, we get 739. So with cases, we count our cases separately, and then we add them up to get our total. Often with a restriction question, and we've done restriction questions before where you have to deal with your restriction first, sometimes you have more than one restriction. And that's the case in this one. How many 3-digit numbers can be formed using 1, 2, 3, 4, 5, no repetition, that are greater than 300 and even? So when I start making my spaces, and if I put just my spaces once, and I try to deal with both restrictions, the first digit has to be a 3, 4, or 5. And my last digit, in order to be even, is either going to be a 2 or a 4. And if I'm supposed to deal with my restriction first, well, I have 2 restrictions. So which restriction should I deal with first, or does it not matter? And if it doesn't matter, if I do this restriction first and I say 3, because I have 3 choices, what number do I put in this last spot? Do I put 2 because there's 2 choices? But what if I chose the 4? If I chose the 4, then I don't have 2 choices, I only have 1 choice. So sometimes I put 2, sometimes I put 1. Should I put 1.5? Oh, that's going to be problematic. So when we have 2 conditions and one of those choices in those conditions overlaps. So the problem here is the 4 is in the last restriction to make it even, and the 4 is in the first restriction to make it greater than 300. How do we deal with that? We break it up into cases. So we need to somehow separate things so that this issue of the 4 doesn't happen. And there's more than one way to separate them, but as a starting example, you choose one of your restrictions, and it really won't matter which one. So let's say we choose the last restriction, because that's our problem. So we make our case 1 we break up that restriction into the last number could be a 2 or the last number is a 4. If we make our last number a 4, well, that means I only have 1 choice for that last number. My other restriction is the first one, but now how many choices do I have for that first restriction? Just 2. It has to be either 3 or 5. And then the middle one, which has no restrictions, we now have to say how many numbers would we have left? We've used up 2 choices, 2 spaces, so we would have only 3 numbers left. There will be 6 numbers that end in a 4. What haven't we counted? What's our case 2? We have to count the last number being a 2. So there's only 1 choice there. Now how many choices do we have for our first digit? 3, because it could be 3, 4, or 5. So you notice as part of showing my work and explaining my work, underneath that decision, I'm showing all of my choices. And it's good to list them because sometimes you'll realize when you're listing them, like here at the beginning, that, oh, there's an overlap of that 4. So this is why I have to break this up into cases. So there's 3 choices here. You've used up 2 decisions. That would mean that there's 3 numbers left. So there would be 15 choices in total. Because case 1 had 6 choices. Case 2 had 9 choices. Adding those up, there would be 15 numbers in total. Yes? Why is this a 3 here? Well, we are using the numbers 1, 2, 3, 4, and 5. And we made sure that our last number was a 2, and so that left us with 4 numbers. There's still a restriction on our first one that it has to either be a 3 or a 4 or 5. The 3 stands for how many choices you have, but you're only going to choose one of those numbers. So if you chose the 5, how many numbers are left? 3 still are left. If you chose the 4, you still have 3 numbers left. If you chose the 3, you still have 3 numbers left for that middle digit. So one of the things to think about when you have these spaces that there's no restriction on and you're not repeating digits is you could say, well, how many numbers did I start with? And here I started with 5 numbers. And when I make a choice here, I'm going to use one of those choices. And when I make a choice here, I'm going to use one of those choices. So 2 numbers have been used up. I don't know which 2 numbers, other than in this case, I for sure know the 2's gone. But I don't know which of those numbers got chosen. But I would still have 3 left, no matter which of those numbers I chose. So this is breaking up with your last restriction, with the restriction on the last choice. You could have done this one also by saying, I want to start with a 4. I'm not going to write this all out, but let's say case 1, I start with a 4. How many choices do I have for this one? I can only be a 2. There'd be 3. This would give you 3 choices. Case 2, what haven't I counted? I haven't counted starting with a 3 or a 5. 2 choices there. Then how many choices would have been here? Well, it could be either the 2 or the 4 then. 2 choices there. How many numbers are left? 3. Add them up and we get 15 again. So if you're breaking up your cases based on a restriction, you choose, do I want to break up my first restriction or break up my last restriction? And it won't matter which one, because counting it will start off with getting 15 in total. And it's not wrong. Some people will say, case 1, I want to start with a 3. Case 2, I want to start with a 4. Case 3, start with a 5. And add an extra case to count it more systematically that way. You will still get the same answer. However, for efficiency purposes, the smaller amount of cases is better because it can be a lot shorter to do. So when I initially chose this, I looked at my 2 restrictions and said, oh, this one, the last number, because it's either a 2 or a 4, if I break that up, for sure it's only going to be 2 cases. And that might be a little bit easier to count. Part B, we now want our number to be greater than 232. We're still using the numbers 1, 2, 3, 4, 5. And for these questions, there's a number of questions that ask you to do things greater than. For these questions, what I always start with my case 1 is I think, what would guarantee that it would be greater than 232? Because if I tried to do this just once with one space, what are my choices here? Can you see that we could start with a 2, 3, or 4, or 5? But then we don't know what to put in space 2, because if we chose the 4, then everything's fine. But if we chose the 2, then we couldn't have a 1 after it because it wouldn't be greater than 230. So we have a problem with that second space because of this 2. So in all of these questions that say how many numbers are greater than, what I like to do is I like to say, what could I start with that would mean that there would be no problems later on? And if I started with a 3, a 4, or a 5, that would count all the numbers in the 300s, all the numbers in the 400s, all the numbers in the 500s. And then it doesn't matter what happens after, because it's going to be bigger than 232. So I do my 3 decisions. I'm saying I'm starting with a 3, a 4, or a 5. 3 choices there. I've used up 1 number of my 5. There's 4 numbers left. And then there's 3 numbers left for 36 total possibilities. That's all the numbers in the 300s, 400s, and 500s. Case 2, then you say, well, what haven't you counted yet? You haven't counted numbers that start with a 2. And now we're looking at, so there's 1 choice for that first space, then we're looking at that second space. So I want to use that same idea that I did at the first space. I said, what would guarantee that it would be larger? So if I started with a 2, what numbers could I put in my second one that would guarantee that it's larger than 232? 4 and 5. So then 4 or, so 2 choices there, and now there's no restrictions whatsoever on the last one. And so we've used up 2 numbers. There would be 3 left for 6 possible ways. Am I done? Have I counted everything? No, what haven't I counted it? I haven't started with a 2, then a 3, one choice, one choice. Are there any restrictions now on our last one? Yes, because it has to be bigger than 232. How many choices do I have? And this is where it's important when there's a restriction to actually write them out. Because if you just think of numbers bigger than 2, you're going to think of 3, 4, and 5, right? But we've used up the 3. So when you write them out, if you just do it in your head bigger than 2 and you write down 3 quickly, you're going to miss the fact that you've already used up your 3. So there's only 4 and 5 left for 2 choices. Add these all up, because whenever we do cases, we add things up to get our total. And we have 44 in total.